Hey everyone, my name is Meet Nagda. I'm from Group 62 and I'm going to be giving you guys the final project update for our project Efficient Dialogue Summarization. The project aims to develop an advanced neural network based dialogue summarization system that efficiently condenses the conversations into natural language summary. Organizations accumulate vast amounts of conversational data from customer interactions, social media, etc. And extracting meaningful insights from these dialogues is very challenging. This is where something like this would help a lot to create efficient summaries of the conversations that have already happened. Talking about the data sets, we have used the dialogue sum dataset, which has four key attributes: dialogue summary, topic, and the dialogue ID. It is also available on Hugging Face. This is steps that we have taken in our implementation plan. First is the dataset preparation, then pre-processing and tokenizing. Further is model selection, fine-tuning of the model, and training the model. And the final step is performance analysis of the model. These are the key metrics that we have used throughout our whole process. First is Rogue 1, which measures the unigram overlap between the generated summary and the reference summary. Rogue 2 is what evaluates the pigram overlap, and Rogue L is what assesses the longest common subsequence between the generator and the reference summary. We have used two more metrics, which one is blue, which calculates the precision of n-grams, and bird score is what helps us understand how both of the summaries both of the summaries are related in terms of semantics. This is the baseline model that we have used. It is a T5 transformer, which is transformer-based architecture that reformulates natural language processing into a unified text-to-text format. Using the baseline model, we achieved a bird score of 0.85, which suggests the model preserved the meaning effectively. Coming on to the models that we are actually experimented with. The first one is a Distilbach CNN model, which is a neural sequence-to-sequence model for abstractive text summarization. We achieved a Rogel score of 0.272 and a high score of in the bird for with 0.899. The second model that we used was Bartlett CNN, which is a powerful sequence-to-sequence model, which is specifically designed and fine-tuned on CNN Daily Mail dataset. We achieved a Rogel score of 0.275 and a bird score of zero point 0.9. Next is the final model that we have actually used. It is a long-former encoder-decoder model. It is a bar-based architecture, but it extends the input capacity to 16,384 tokens, which enables it to handle lengthy documents really effectively. And dialogues being something that have really large length, this is where a long-former encoder-decoder would really shine. We achieved a Rogan score of 0.44, Rogue 2 score of 0.81, and Rogue L, the LCS one of 0.36. We achieved an incredibly high bird score of 0.91 and a blue score of 18.61. These are the sample results that it has generated. To conclude, the LED performed other models, which basically demonstrated its effectiveness in capturing and summarizing information from long documents. Some of the limitations that we faced with transform-based summarization models is their tendency to generate repetitive or overly generic summaries. Hybrid approaches such as RNNs and LSTMs with our transformers can further improve the coherence of generated summaries. We all have prior experience in NLP tasks, including text classification and sentiment analysis. These are some of the references that we have used during our project. That is all that I have for you guys today. Thank you and have a nice day.